Thank you so much. Forgive me for having many tabs open. I'll take a very short time. Today is not my day. But the key idea is this is a challenge, a continuation of what we've been doing within the Natujenge initiative, which is basically an initiative by Meliora to help us bridge the gap between what we study in school and what we do here in the industry. So the key objective is to ensure that whatever that we learn, I know there are some experienced people here, whatever that they have been able to learn and apply at work, some of those concepts have taken years for you to grasp them. So we are hoping that we can bridge that gap and allow the 21-year-olds and the 20-year-olds to actually do what we did when we were 30. So that's the basic idea, and we believe it can be a tool to move us from one level to the other. So the key idea here within the SS7 challenge is we want to build a basic SMSC. So that's the whole idea. But for us to build basic SMSC, we must appreciate some stuff about telecommunication, GSM architecture, what SIGTRAN is and SS7 is. And so the idea of the challenge is that we want at the end of 8 weeks to be able to simulate such a thing, where the SMS app is created by us that sends a message to the SMSC through an SMPP bind or even a HTTP API. And the SMSC forwards the request or makes a call to the HLR to ask for the routing information. The HLR gives the routing information and we're able to forward the message to the switch that the guy is connected to. So the whole idea is just an SMS MT call flow, and most of you might be aware of that. And the key idea is that this is supposed to be done as a group work. So there is a lot of work that you're going to learn in terms of dealing with SIGTRAN stack, specifically the protocols that are here, and being able to develop network applications there. And so the key idea here is we will have a project which will be available on GitHub that will allow us to show the SMSC, the simulator for the HLR, and the simulator for the switch. And the SMSC can actually be put in a network. We are hoping that we'll get some partners there. So it's going to happen for the next 2 months. The context is this, and this is for the judges, that these guys who are presenting today, they have gone through the week 1 challenge, where they have done a bit of research on SS7, GSM network architecture, and they have a bit of research on SIGTRAN. We've helped them a bit, but most of them are green. They don't, some of them did computer science. They have no idea what SS7 is. Some did telecommunications, so they probably have some idea of what is happening. So the key idea is that the groups have done their research, and in the last 1 week, they have watched a lot of videos. Some of them have read RFCs and technical specification documents, and they are able now to explain to us what SS7 and SIGTRAN is. So for the judges, the key idea is check the breadth of the presenters. We have 6 groups, and we are hoping that we'll keep time. 6 groups, check the breadth and the depth of the presentation. I hope you have a piece of pen and a paper where you can record some things about each and every group and maybe the presenter. And then check for any errors or corrections. To save on time, I think what we could do is, if you discover that a certain presentation has an error, or maybe you need some clarity, you can ask. But if there are errors, maybe we can wait and share the corrections at the end of the session. And this is for the people who have the experience and will be judging what these guys are doing. The reason for this presentation is because we're going to pick some people that will go to Safaricom Engineering Summit tomorrow from the community. So I hope everything is clear, and thank you all for showing up. I know we have Collins Oluoch, a good friend of mine, who has a lot of experience in telecommunication. We have Walter Onyango also, Grace, a special connection, and then we have Juliet. who is also a very good friend. I don't know whether Alan is here or another guy called Anyona. So if Anyona, you are here, you can also probably introduce yourself. I think he had indicated that he'll join. So at this particular point, I want to hand over to the judges so that they can mention their names and basically tell us something small about themselves. And hopefully in the next 10 minutes, we'll be starting with group one. Marlene, over to you. Or maybe we can go to Walter. Maybe you can say hi to the team.
Good evening, everyone. Hope you can hear me.
Yes, very clear.
Yes, as my name has been said, I'm Walter Onyango. I'm a telecommunications professional with about 16 years of experience in CS core network. I started working with a telecommunication provider, basically Safaricom, for some years before joining my current employer, Nokia. I'm a graduate of electrical and computer engineering. Thank you.
Thank you, Walter. I guess that is JQuat. That's why I heard that.
Yes, that is JQuat. We were the first lot.
Okay, thank you. Juliet.
Good evening, everyone. So, as mentioned, my name is Juliet Ongoro. I currently work at M-Pesa Africa as a service operations manager, but it's a role I started in December last year. So prior to that, I was working in Safaricom. I have about 14 years experience. I worked in different sections. So I worked in the network management center, which is, I think nowadays called the Service Operations Center, doing monitoring of the GSM network. And then I moved on to VAS. So I have extensive knowledge in the SMSE and signaling, and then also experienced in roaming. Actually, most of my time was spent doing roaming about, how many years? Many years. Yeah. So glad to be here. I'm a graduate of UON. I studied electrical and electronics engineering. So all the best to the presenters today.
Thank you, Juliet. Maybe we can give a chance to Grace.
Good evening, everyone. I am Grace Kimani, special connection to Kamochu. He's my husband. And I'm a graduate of University of Nairobi. We were in university at the same time with Juliet, just that she was a few years ahead of me. And we met again in Safaricom when I joined as a graduate engineer. And then I joined the VAS team and I worked together with her in roaming and VAS for several years. Then I moved to vendor side and working with Global WaveNet, also in telecommunications. And I really love telecoms. This is something I'm excited about. All the best.
Thank you, Grace. And finally, I think Collins.
I hope I'm now audible.
Yes.
Okay, so I have to switch devices. Okay, I'm Collins Ochen. I'm a graduate of Moi University, Chep College campus. I did computer science. I have around, I think it's around 13 years around messaging nodes. I work at Safaricom as a VAS planning engineer. So my journey, I started working as an integrator first some years back. Then I moved to working as a vendor, still on the messaging platform, and now working as an operator under the messaging node. So happy to be here, and hopefully we can work together with Kamochu on this journey of having the first SMSE within Kenya. Thank you, guys.
Thank you, Collins, and thank you all for accepting the invitation. I don't know whether Anyona is around. I knew the guy was meant to be here. He had volunteered, but if he's not around, I think we can proceed. Yes, over to you, Marlene. I guess you can take us through I don't know whether the judges have any specific question regarding what I mentioned earlier. Maybe you can raise a question. After the last presentation, I'll provide a link to you guys where we can meet briefly and get some feedback. Feel free to ask some questions as long as we ensure that the session is brief so that we don't overshoot. Yes, and I think we are doing quite well as far as the program is concerned. Marlene, over to you, and looking forward to hear from you guys.
Thank you to our judges. So we'll jump straight into the projects. We'll start with group 1. So in the order of the numbers, group 1, 2, 3, 4, 5, 6. You have 15 minutes each to present. So I hope all of you are ready. So for group 1, we have Boniface Mutei. Group 2, we have Mike. Group 3, we have Polycarp. Group 4, we have Brian. Group 5, we have Amos. And group 6, we have Franklin Kiplagat. So I hope all of you are ready. And Boniface, if you're ready, you can take over.
Hello, everybody. Can you hear me?
Yes,
Yes, we can hear you, Boniface.
Okay. So my name is Boniface Mutea. I'm a student at Multimedia University. I'm pursuing a course in telecommunications engineering. So I'm here on behalf of Group 1. Well, I'll tag some of my team members to help me with the presentation. But I think I can get started. Do I need to maybe share something, or it's just presenting?
You can share your screen or the presentation. Or
Okay,
do you have a
okay.
Yeah.
Okay, so over the past 1 week, we've been basically focused with demystifying the SS7, which is the signal systems number 7, and the SIGTRAN protocols. So let me start with SS7. I think I can maybe give a small brief history about the evolution of SS7. So initially, before we arrived at SS7, which was first introduced in the year 1988, we did have SS6 and previously SS5. So with the signaling system 5, it largely used the common associated type of signaling. This is a type of signaling whereby it employs a single signaling channel. It largely employed the common associated signaling technique, which was also known as the in-band signaling. However, the earlier versions of the signaling system had some limitations, whereby there were issues with the security measures in the system, whereby someone could maybe send some tones. And can you still hear me?
Yes.
Okay. Sorry about that. So I was saying that the prior versions of SS7, they initially used a single sort of signaling channel, but with the advance to SS7, we employed the common channel signaling. This is a situation whereby we have got the signaling channel and the data channel. So signaling happens in one of the channels, and then communication happens on the other channel. So it becomes difficult for someone to access the signaling information in the SS7, which was not the case in the earlier versions of SS5. So several other advantages of SS7 were due to the introduction of the 2 channels. It could support high bandwidth capabilities, It also supported connectionless mode. The data rate itself increased from 24 kilobytes per second, which was the case in SS5. But with SS7, we can now utilize up to 64 kilobytes per second. So going forward, SS7 usually has got what we call nodes, and these nodes are basically signaling points in the SS7 network. Some of these nodes are usually we have got the service switching point, the signal transfer point, and the service control point. I will quickly go through the various functions of the nodes in the SS7 network, and I'll start with the SSP. So the service switching point acts as a it basically acts as a telecommunication switch in the SS7 network. So they are basically responsible for creating the signaling units. With the signaling transfer point, these are basically the routers or the gateways in the SS7 network. They are responsible for connecting various components they are responsible for connecting the SSPs to the SCPs. Then the SCP, the service control point, it acts as an interface between the telecommunications database and the SS7 network. It is responsible for providing database access, and it is largely used with the TCAP protocol, as we will see in the upcoming sessions. So the nodes which I've talked about, they are interconnected with each other using links, in which we have got various types of links which interconnect the various components of which interconnects the various nodes. So to begin with, we do have the access link, which basically connects the STP to the service control point. So this A-link, Ella?
Yeah, you have 5 minutes, so if you could kindly summarize.
Okay, sure. So yeah, as I've mentioned, we have got various links which interconnect the various nodes in telecommunication in the SS7 network, which are illustrated there. Then moving forward, we can see the SS7 stack, in which it employs various levels, which as can be seen, they correspond to various levels in the OSI layer, from the message transfer part to the SCCP. Then I'll mention a little bit about the messages which are transferred in the SS7 network, whereby we have got the FISU message. This is a type of message whereby it is transferred whereby no other signaling information is available on the network. So if an example of the FISU can be an acknowledgement message, among others. Something else worth mentioning is the SIGTRAN. Okay, let me talk a little bit about the SIGTRAN. So SIGTRAN, it's something that was built to enable the SS7 to be able to communicate over the IP networks. Due to the evolution from the circuit switched data to the IP-based communications, there was a need to adapt the SS7 to be able to offer services over the IP network. So basically, that's the function of the SIGTRAN, in which it has got various adaptation layers, which due to time, I'll not be able to go through them. Okay, what else? Yeah, I think I'm done. I don't have much else to add on, but I do want to appreciate the content that was available to us. We have learned a lot. I might not have been in a position maybe to address everything sufficiently, but it has been an awesome challenge. The materials were handy, and I really appreciate the opportunity. Yeah, thank you.
Thank you very much.
Okay, thank you, Boniface. We'll go in straight to group 2. Mike.
Oh, hey, hello everybody. My name is Michael Wanjiru, and I may begin by saying that everything in telecommunication, in signaling and SS7 can be defined as the procedure and protocols by which a network element in the public switch network exchange information over a digital network, right? Okay. Before SS7 there was S6, and before SS6 there was SS5, as the previous person had said, and they chose in the SS7 they chose to implement the out of band signaling so that they can tackle some of the challenges that had been experienced before, that is interference in the transport layers, in the trunks, the transport tracks, so the outbound signaling divides them into separate transports into different transports. In SS7, this is the basic architecture of SS7, where SSP is connected to the public switch telephone network, which in turn connects to the signal transfer points and the SSP. SSP, which now connects to the end users. It's the terminating points. The last one, let's go to the next one. I think I'm kind of going fast. The fourth slide. The SS7 has switch points, right? Each node, it has nodes, and every node in an SS7 is known as a switch point, and they are divided mainly into three. That is the signal switching point, SSPs, which refers to telephone switches of the end tandems, or the person with the person at the other end, equipped with SS7, which originate or terminate calls and also initiate them. So that's our. Then there is the signal transfer point, refers to the packet switcher network responsible for receiving and routing incoming signal messages towards the proper destination. So the STP is responsible for routing. Then there is the signal control, which refers to databases that provide information necessary for advanced calling. When you go to the slide that is currently on, you can see the different types of links connecting different types of nodes to each other. Because of time, let me go to the next slide, because it has been explained by the previous one. So the next slide, please. In this slide, we are comparing the OSI model to the SS7 protocol. The OSI model to the SS7 protocol. So the two are different and similar. Yes, similar, because some of the layers in SS7 does similar things as to what the layers in OSI model used to do. And point to note, SS7 predates OSI model, though the OSI was kind of common in some layers before then. Yeah, so if very quickly I can go through the different layers. Very quickly we go through the different layers. We have the message transfer part, which is the physical layer. This layer is responsible for, okay, the physical layer now is, this one is responsible for the data representation. It's the one which decides, it's the one which now converts data into either waves, the light signal, depending on if it is fiber, right? Then we have the message transfer part, which is two, which is the link layer. Okay, the data link layer. The data link layer determines it's the one who chooses which link, right? Then we have the networking, the network layer. That is the one which is used for addressing. We have the transport. It breaks down the it breaks down the message into segment and sends it over. And when we come to the layers in the SS7 protocol stack, we start with the message transfer layer. This one aligns itself with the physical layer in the OSI. And this one, it does almost the same thing. It defines the physical and the electrical characteristics of the signaling links of the SS7 network. From the previous SS7, SS5, it was almost 24 bits, but when we move to SS7, it becomes 264. Now the second layer is the message transfer part. In this layer, it's where the functionality is. It ensures that the two endpoints of the signaling can reliably exchange signals messages. So it checks on the two layers, that it checks on the capabilities of the two layers, and other than that, it also does error checking. It flow control and sequence checking. The third layer is the MTP3 also, which relates to the next slide, which relates to the network layer. This is the network layer that implements the MTP3 control. It does end-to-end routing of SS7 messages, so it's the one which does the routing for the SS7. The routing level is defined the NTP3 header, which contains the OPC, the DPC, and the SLS. Some functions of the layer include the link alignment. This checking whether all the links are are aligned well, so that the message, the transfer protocol can proceed. There is the transfer prohibited. It checks if there is any node down. The load sharing, that is division of the workload, or the load, the message. There is the changeover and the change back. Then we have what we call the signal connection protocol, the CCP. It works as a transport layer and uses the service of MTP3. It does segmentation and reassembly of large messages if required. In telecommunication, there is communication in between. There is STCP layer for STCP has the global title. It contains the global title. An example is your phone number, which has, when you include the 254, the Kenyan code, it gives a unique globally. Yeah. One of its function, it does the SSN management. An SSN is a number given by an application to a phone. Yeah. It also does international translation. You have the ISUP protocol layer. It implements the protocol. This layer now implements the protocols. The protocol messages required for call, control, functionalities, and voice circuit management. So the voice circuit on SS7 go through two lines, that is the E1 and T1 lines, where each line has logical channels. A single channel is required for a call. And a single call is always required for a call in each CIC. Let me jump to SIGTRAN. Basically, SIGTRAN is SS7 over IP. So when the technology of IP network came, SS7 had to evolve, and that's when the SIGTRAN protocol came to. So SIGTRAN is a protocol suite intended to transport signaling protocols over IP and are extensions of the SS7 protocol family. It supports the same application and call management paradigms as SS7, but uses internet protocol, IP transport called stream control. So the lowest layer in SIGTRAN is the IP layer. That is the lowest layer in SIGTRAN, and now it's responsible for most of the routing, the voice over IP. Yeah. So the SIGTRAN has three layers: the adaptation layer, which is the MUI3, the SUA, the M2UA, the M2 user adaptation, the M2PA. So this layer uses the service of SCTP protocol and provides the services to an SS7 layer. So adaptation. So it's basically SS7 with some few changes to, okay, it's with IP. So as I've said in the definition, it's just signaling of SS7 over IP protocol messages. Okay, the next slide. STP provides the transport. The STCP provides the transport protocol for SIGTRAN, user adaptation layer, message across an IP network. The UIA provides the STCP adaptation of seamless backhaul of user messages and service across an IP network. So basically, the SIGTRAN is, okay, it's an addition of over the IP, over the internet, because the internet is growing, it's becoming bigger. So SS7 had to adapt. So the SIGTRAN came there. Now to the second last. Okay, that is the SS7 versus SIGTRAN. Now you can see the basically
you have 2 minutes. You have 2 minutes, so you can conclude. Yeah.
Yeah. So okay, then I can go to the last one. I have more detail over the two side to side. So now the differences between SS7 and SIGTRAN. So SS7, it's a legacy protocol in telecommunication. The media and the signaling part both uses SS7 protocol, and on the other side, SIGTRAN is a new protocol in telecommunication. Only signaling uses the SIGTRAN protocol. In SS7, it uses TDM-based E1 and T1 links for transport and SS7 messages, while in SIGTRAN, it uses IP network for SS7 signaling. Basically, the one is mainly link, the other one is using the IP calls. So, okay, it uses the IP over network. It uses over network. This one is using the E1 and T1 links. The next one is special hardware is required for SS7 links. This hardware is SS7 card that implements MTP2, MTP1, and their logic. Okay, then in the other one, you don't need those special hardware is required. The SIGTRAN uses an Ethernet card, which is available on all computers. In the SS7 protocol standard defined by the ITUT, where the protocol standard are defined by the IETA. And the last is the complex implementation of the network layer and easy implementation of the network layer on the SIGTRAN. So okay, the two are almost similar. They do this almost a similar thing, but one has the network capability of an IP, and the other one does. The other one uses the SS7. You have to have had specific hardware in order to use the SS7. To use the SS7, which basically rose the expense or cost. Well, in the SIGTRAN, it opened up to software, because hardware. Okay, the hardware it comes in every machine. It's just an Ethernet card. I believe I have gone through my whole slide. Yeah, there is more to go through, but that's what I had. That's what I had compiled for now. Yeah. Thank you.
Okay. Well, thank you very much, Bwana Michael Wanjiro. You didn't say what you're doing and which university you are from. Just maybe you can mention that. Yeah.
My name is Michael Wanjiro. I am from Kirinyaga University. I'm from Kirinyaga University. I'm doing a bachelor in mathematics and computer science. I was representing group 2. Yeah, that's me.
And thank you very much, Mr. Michael. Marlene?
Thank you, Mike. We'll move to group 3. And group 3, we have Polycarp. Polycarp, are you ready?
Good evening, Polycarp. I'll share my screen. I'm representing group 3. I'm going to be brief and quick. Let's start with what is SS7. SS7 is a signal system transmission protocol that enables management and billing of telephone calls and routing as well. Other names of SS7 are Signal System 7 or CCS S7. The history of SS7, it went its initial international adoption in 1988, and the current version was made in 1993. It is used for landline and mobile phone services, and that includes 5G network that you have today. We're going to see how SS7 works. SS7 signaling can function across internet protocols. This makes it possible for it to run across different protocols in the network. SS7 uses out-of-band signaling called the common channel signaling. Unlike SS5 and the previous versions, SS7 has high security. If you can see, since the previous versions of the previous versions of signal protocols were vulnerable to hackers, and due to the inbound signaling. But SS7 uses out-of-band signaling. As you can see on the screen, it's a typical architecture of the SS7 system, where we have SSP and STP. The service switching points is the one that we have as SSP, signal transfer points, and the service control points as SSP. SSP are the starting points on the SS7 network and can start or end a call. STP functions as connected switches and are used to route the control signals. The SCP is put up and provides administrative features or decide on how calls are routed. We are now going to see to understand how the SS7 works. I'm going to jump over to the SS7 signaling stack. As the OSI model, the first three layers, as you know from the OSI model, are in the SS7 signaling stack. That's the physical layer, the data link layer, and the network layer. The first three layers helps in the transmission of signals, and layer one, the physical layer, is responsible for the signaling data and defines the physical and electrical characteristics of the link. We have the layer 2, which is the data link, which provides a link layer function, making sure that the messages are exchanged reliably. Then we have layer 3, that is the network layer, and depends on the service of layer 2 for providing routing, message distribution, and message discrimination. We have TUP, telephone user pass, used to set up a telephone call between two SS7 nodes. Number 5, we have integrated service user pass. Is the name is the same as TUP, but it is more sophisticated function available with primary rates. Then we have number 6, that is SCCP, signal connection control part, that runs above MTP layer and provides functionalities similar to UDP and TCP layers over TCP/IP protocol. Then we have number 7, that is TCAP, transaction capabilities application part, that is used to implement functions and related to origination and termination of actual telephone calls. Then we have ACE, that is a MAP, the mobile application part, used in GSM mobile telephones to pass information between the network components. Then number 9, we have intelligent network application part that is used to implement services within a network. And the last, we have operation and administration application part that is used by network administrators to monitor the network. I'm heading to the last part of presentation. Have SIGTRAN. SIGTRAN is a protocol suite intended to transport signaling protocol over the internet. The use of SIGTRAN is typically for signaling gateways that allows voice over IP network to interwork with traditional telephone network using circuit switching and SS7. I'm done presenting my slides. This is my last slide. The use of SIGTRAN, it allows voice over IP network to interwork with traditional telephone network using circuit switching and signal system 7. Thank you, guys. I'm done presenting today.
Thank you, Polycarp. Maybe you could also mention what you're doing. I think you didn't introduce yourself extensively.
Sorry, I'm Polycarp Kimure. I'm from Oseno University, 4th year. I'm taking computer technology and science.
Thank you very much, Polycarp. I hope you're not related to the one Polycarp, you know.
He's a friend of mine. Thank you.
Thank you. Maybe Marlene, you can help us invite the next group also. As yeah, in case judges, you have any hot questions, I think you can also ask to any of group 1, 2, and 3 in the event you do not want to forget. I think we are doing well on time.
Group 4, Brian Kitunda.
So I am Brian Kitunda. I recently completed from Oseno University, currently working with the Meliora team. So I'm here to represent Group 4. The other members are Janina, Mary, Gilbert, and Corey. You can stay, just hang around. You can contribute where you feel like something is missing. So we started by looking at GSM, which is the global system for mobile communication. We wanted to appreciate where we're coming from. So with GSM, we have some features that GSM supports, including international roaming, voice clarity, and all that. But what was important to us were the subsystems that come with GSM. One of them being the BSS, which is the base station subsystem. We have the NSS, which is the network and switching subsystem. And we also have the SS, which is the operating subsystem. We are going to look at each of these subsystems, hopefully in the next 5 minutes. So BSS is, it handles the traffic and signaling between the MS and the NSS. NSS is yet another layer. So yet another subsystem. At this point, you have what we call a mobile station, which is your phone, and it is made up of the mobile equipment and the SIM. These two make up the mobile station. But again, the BSS has two components. One is the BTS, the base transceiver station, what we call the boosters. Secondly, many BTS are controlled by one BSC, for instance. So you can have 3 BTS being controlled by one BSC, and the BSC is the base station controller. On to the next subsystem, the network and switching subsystem. This is the core network of the GSM. And some of the components, I think we've all seen the HLR somewhere in the document. One of the components is the HLR, another one is VLR, and another one is the IR. So these people like a lot of the acronyms and all that. So, and another subsystem is the SS, the operating subsystem, mostly for monitoring, control, maintenance, and all that. So now let's look at some major components of the NSS. So this makes up the mobile switching center. And one of the components that we have in this is the VLR, which is the visitor location register. Assuming in Ruiru, and then you're moving to Roysambu and all that, your details we need to save that, because each time you're moving from Ruiru, maybe you're being served by BTS X, now you're in Roysambu, BTS Y is serving you. That record needs to be kept, and that is the role of the visitor location register. Another one, which is very important, is the home location register. This one has details that do not change so much, like your details, your ID proof, and all that. Another component is the EIR, your devices. They are all the mobile equipment. They are all stored in that database that keeps track of all of them. Then we have the OMC, which is the Operation Maintenance Center. This is part of the OSS, the operation. Then we have the AUC, the Authentication Center. And we felt that we needed to define PSTN, which is a public switched telephone network. This one connects with the MSC, the one that we've been discussing. And we also felt the need to define SMSC, which is the Short Message Service Center. So that was the brief part on GSM. And here we have a diagram. You can see an MS connecting to a BTS, many BTSs being controlled by a BSC, and many BSCs being linked up by the MSC, which has all these components: HLR, VLR, AUC, EIR, PSTN, and then you have the operation support subsystem. On the other side, we have the OMC. Yeah, so that's it for GSM. Now on to the next guy, and then that is SS7. So we defined SS7 as a protocol that defines how the network elements in a PSTN exchange information and control signals. So informations and control signals, all very important. But how does it happen? So we looked at the two modes that exist: the channel associated signaling and the common channel signaling. Each and every other group has talked about this. We all know the drawbacks that come with channel associated signaling, and we all know how well suited the common channel signaling is. So we'll not look so much into that. The signaling points, SSPs, STP, SCP. The SSP and SCP are commonly referred to as the signaling endpoints in this. Then the STP is in between, it's the router. So we'll not also look so much about it. But one thing to note is that all these signaling points are identified by a unique address called a point code. This is the equivalent of an IP address in the system that we all understand. So make note of the point code. So SSPs, STPs have all been discussed. The CP has all been discussed, but we'll look at something here. The SSP, SCP, which is the service control point, mostly we communicating to a database application. And one key protocol in that is what we call the transaction capabilities application part, as we'll see in the coming slides. The signaling links, they've been discussed. We have the O links all the way to F links. I'm sure by now we've mastered them. So we'll just skip that part and come here. Now the protocol stack. We have MTP1 all the way to MTP3. Then we have a CCP, TCAP, and a layer above for all those user parts. So for instance, MTP level 1 links with the physical layer, electrical, and all those characteristics. MTP2 data link layer, I'm sure if you did a course on computer networks, you remember when we did error detection and flow control, things like CRC, all those algorithms for checking errors and all that. Then MTP level 3, that links to the network layer, but there's a catch here with SCCP. SCCP does two things. One, it does some roles that belong to the network layer of the SI model, and still some other roles that belong to the transport layer. But it all boils down to those two things. What are the network capabilities? So let's say, you see, when you talk about the SS7 network, we are talking about a network, a single network, mostly when you're talking about it right now. But what if we wanted to do a global call, for instance? That means we need to know where we're going. And sometimes you can have a clash in the point codes. So that is the concept that most of us are talking about, the global title translation. So instead of SCCP will help you to know that, yeah, maybe they match, but this belongs to a certain network and the other one belongs to a different network. And always above this SCCP will always have the TCAP. As you can see, ISAP, that ISUP, doesn't have a layer below it. Like you see, it's MTP level 3 and then ISAP. But SCCP serves TCAP. So you can't have TCAP without SCCP. But you can see clearly on the other side here, ISAP all alone. So SCCP serves TCAP, the transaction capabilities application part. So we'll skip all that and come to TCAP. So TCAP, there's something we call the intelligent networks, IN. So TCAP enables deployment of advanced intelligent network services by supporting exchange of non-circuit related data or information between SPs using the SCCP connection service. You see here, using the SCCP connection service. So it is used in queries and responses sent between SSPs and SCCPs and all that. It also provides a means for SCCP to SCCP communication via STPs. And one of the services that TCAP offers include free phone, calling card, wireless roaming, and all that. Then we look at ISAP. This is another protocol. This is mostly for calls. So it sets up, manages, and releases trunk circuits that carry voice and data calls over PSTN. So we look at a typical call flow for ISAP. We have something called an initial address message. We also have an address complete message, an answer message, a release message, and a release complete message. The diagram in the next slide will show this clearly. So caller A is calling caller B. So they send an initial address message. Caller B is found, they return a address complete message. And it starts ringing on the other side, toot, toot, and all that. Then caller B answers the call. So we send an answer message. So between this point to this point, they are talking and talking and talking. And then at some point, caller A decides to terminate the call. So it sends a release message. Caller B has to acknowledge that by sending a release complete message. So that's a typical ISAP call flow. So signal units in SS7, we have the FISU, the LISU, the MSU. The FISU fill-in, send, they usually send when nothing is actually happening in a link. The link status used to control link alignment and indicate status of a SP. The message signal unit, it is used to carry all call control, database query, response, network management, and network maintenance data. So those are the signal units, the only three. Now, so why are we even discussing SIGTRAN? We have the SS7 network, but one thing for sure is that you cannot assume IP. So SIGTRAN is basically SS7 of IP. So introduce a layer below it. We can call this, mostly I've seen them using either physical or Ethernet or all of that. Then that protocol that we did in the hackathon, SCTP, transport layer. This could be UDP, this could be UDP, this could be TCP, but SCTP was made purposely just for this. You remember in Natujenge season 1, when we discussed SCTP, all those features, multi-homing and all those features. Then above it, we have adaptation layers. We have the M3 UA. You could use M2 PA in combination with MTP3. It all depends on what network you're trying to connect to. So it doesn't. It's not some guesswork or something. It's something that it's a decision that you have to come to. Then above them, the normal things, SCCP and TCAP and all application parts. The remaining bits are all the same. So that's it. That's what we have for group 4. Thank you.
Thank you, Brian. You finished, I think, 2 minutes or 1 minute plus before time. Just like our brother Polycarp, we really appreciate. I don't know whether the experienced, the telecommunication professionals have any quick question or to any of the groups 1 to 4. So if you feel like you have a quick question, you can feel free to shoot as Marlene moves us to the next level.
Thank you, Brian. We'll move to group 5. Amos?
Good evening. Yes, my name is Amos. I have completed college, Masai University, awaiting graduation. Allow me to share my screen. I'm here representing group 5 on this challenge. Yeah, so let's dive right into it. The first thing that we began is looking at what SS7 was. And the people who have gone before me have defined SS7. But again, just as we are discussed in our group, I'll just mention that SS7 defines how the network elements within the PST and the public switched telephony network operate. That is, there are several protocols that are defined within SS7 that actually help all these network elements to talk to each other, therefore, and they are able to understand each other, therefore ensuring that messages are able to be relayed from one point to another. Again, it's important to note that SS7 just came right after SS6 and SS5, whereby prior we were using inbound signaling instead of outbound signaling. So inbound signaling brought issues like we are using the same channel for both control and data signals. So many people, the callers could have access to the control channel and they could do malicious things. Now with SS7, you realize that the data channel and the control channel are different. So the control channel is usually not accessible by the callers, making SS7 much secure. Yeah, let's move right into the services. Okay, just an overview of the services provided by SS7. There are several protocols which are defined, which help in call setup, in SMS, mobile phone roaming, subscriber authentication and billing, and even call forwarding. Another thing that I'd like to mention is the architecture. In SS7, there are 3 major components. These 3 major components define how maybe a call is routed, how an SMS is routed from one point to another. Now we have the signaling switching point, SSP, the signaling transfer point, STP, the signaling control point, SCP. Yeah, so we can just mention that SSP, majorly, it's like a switch, right? So it is the first entry point to the network. And then STP acts like a router, right, in the network. So it redirects packets to their appropriate destinations. And SCP helps in connecting, or rather accessing, the database for any call processing or any other further action. And then another thing to mention also in my slide 5 is, as much as we have all these components within the SS7 network, there should be a way of communication. Now, there are several links that connect SCP, STP, as well as SSP. The links are labeled from A all the way to F, and each letter stands for a specific type of link. So, for example, if we talk of a link A, which is the access link, which connect the SSP to STP, and then the bridge link, cross link, all these links, of course, they define the interconnection between the individual components within the SS7 architecture. Yeah, labeled, of course, with their alphabets. Yeah, another thing that I'll want to maybe talk about is the SS7 stack. The SS7 stack, it's basically similar to the OSI model, because the physical layer is just mapped to the physical layer, and the MTP2 as well as MTP3 just mapped directly. But again, it's important to note that the SS7 stack is organized in levels. So you have level 1, MTP level 1, level 2, level 3, and level 4, which is layer 4. Another thing maybe to note also is the several protocols which define, depending on the type of message that someone is sending over the network, a given protocol is chosen. So for example, if you want to make a voice call, maybe you could use ISAP or TUP. Now, depending on anything that you want to do, the already defined standards of operation within the SS7 protocol, rather the SS7 system. The last thing that I will want to highlight is the SS7 call setup, which I found quite interesting, because anytime, say, subscriber, the first subscriber wants to call another subscriber, several things take place. So for example, in this diagram, the switch, that is switch A, identifies a link to switch B. Now this link should of course be idle. Now once the link is identified, it sends a message we call the IAM, that is the initial address message. And the initial address message contains several things, among them being the destination switch, that is B in this case. And then another thing, maybe the initial switch, that is A. The trunk selected, that is the path which the message will flow all the way to the other subscriber. And lastly, it defines who is calling and who is being called. Now, once the message gets relayed to B again communicates back. Okay, so sorry, first B identifies whether the subscriber being called is available and if they're idle. If they are, then they send back a message to A, and that message is what they call as address complete message. Now just telling A that, yeah, this guy is available, and immediately B receives sort of some ringing tone, and then A also can be able to know that B is the subscriber at B is available. Now, once the subscriber at B receives the call, a link is established where they are able to transmit the voice. Now, after the voice has been transmitted and maybe one of them decides to hang up, of course, the one who hangs up sends a release message to the other party, and then the other party responds with a release complete message, which makes now the trunk to be in idle state. Yeah, basically that is what we covered for group 5. I don't know whether there are any questions or comments, but again, here are some of the references that we used, in addition to the references that Kamuch had shared. Thank you.
Thank you so much, Amos. You've kept your time. And yes, thank you for the presentation. Again, maybe I'll give 30 seconds. If there are any burning issues from the experienced professionals, you can shoot. And if you do not shoot them, Marlene, you can take over in 20 seconds.
Probably just to make a comment, we are happy with the presentation so far. So for the presenters, don't get discouraged that we are silent. Yeah.
Franklin, then you can take over. Group 6.
I'm Franklin. I'm a student at Dedan Kimathi. Can you hear me?
Yes, we can hear you, Frank.
Okay. I'm a third year student at Dedan Kimathi, pursuing computer science. Okay, so I'll be presenting for group 6. Okay, allow me to share my presentation. This week, I've been able to learn about the SS7, that is known as signaling system number 7. So it is a telecommunication protocol standard that defines how the network elements in a public switch telephone network. It was developed back in 1975, and it's used to tear down telephone calls. It is a 4-layer protocol stack. So we have the lower MTP, MTP1, MTP2, and MTP3. And also SCCP is also part of the lower 3 layers of the SS7 stack. Then we have the ISUP and the TCAP, which are considered as users of the MTP and SCCP. As you can see in the diagram, so we have the MTP1, MTP2, MTP3, the SCCP, the ISUP, and the TCAP. So for SS7, we have signal points, which are the nodes in an SS7 network. So we have the service switching point, which act as the switches in an SS7 network. We have the signal transfer points. They act as the routers or the gateway. And then we have the service control point, the SCP, which provide access to database. So some of the applications of SS7 are call setup, routing and teardown, call forwarding, automated voicemail, call waiting, conference calling, and call ID. SS7 was an improvement to SS6 and SS5, which used inbound signaling. In inbound signaling, it used a single line for both voice and data, which was it used more resources, and it was more susceptible to attacks by hackers. And it came out with another system. It uses outbound signaling system, which separates the signal from the data, which thus improves the speed of call setup time. It's efficient use of voice circuit, and it supports intelligent networks, and it also supports anytime signaling. And also we have SIGTRAN. So SIGTRAN is Signal Transport Protocol. It provides the interoperability of SS7 signaling to operate over internet protocol, IP-based network. So it's basically it makes SS7 be able to use the IP to pass voice and data, and it also allowed for a person to be able to or a person to be able to call, and the call will go through the IP network. I'll finish on SIGTRAN adaptation protocols. We have the SCTP, the Stream Control Transmission Protocol, the ISDN, the Integrated Services Digital Network, the MTP, which is the Message Transport Part, and the SCCP, the Signaling Connection Control Part. That's it from Group 6. Thank you very much.
Oh, Frank, thank you so much for doing that within a very short time. I think we are doing well in terms of time. Marlene.
We can now give the judges a chance to give their feedback and comments.
Yeah, and I think all of them must give something.
Yes.
Yes, and then we can meet briefly and decide on who is going to Sarit tomorrow.
Yeah.
Or which groups have done very well.
Okay, I don't know. Can I just maybe I start?
Yes.
Okay. Thank you everyone for taking your time to prepare the presentations. I know it's a lot of materials, especially considering that most of this stuff are not they're not taught at the university in the courses that we are doing, especially comscience, IT, maths, computer. I know it's new stuff, so it must have been you must have taken a lot of your time to go through the materials to come up with the presentation. The presentations were good, and just one overall comment. I can see there are some groups that went ahead and gave a sample call flow. Maybe since our main agenda is to try and develop an SMSC, it would be good if in future presentations we try to deep dive into the protocols related to SMS, basically the map message. I think I didn't see. Did I see anyone mentioning map? No, I don't think so. But anyway, it would have been good to deep dive into that, and maybe the message flow wherever we are trying to send a message, but either sending a message from the application to the message center to the mobile subscriber, or vice versa. It would have been good. So maybe that as a point of improvement, we need to start digging deep into protocols related to what we are trying to set up, what we are trying to achieve, so as to show that we are trying to learn more on that step. I don't, for now, let me not give comment on group per group. We can give it after we come up with a rating. Thank you.
I could go next. My sentiments are similar to Walter's in regards to the effort that was put in to prepare the presentations. I know signaling is not an easy topic. It's not easy to understand. And you basically getting the information and reading it and trying to understand it, and then present it to other people and ensure that we get to understand what you're presenting. So kudos to all of you for the effort you've put in. And I think across the groups, there's been effort to try and understand the protocols. And I liked the fact that you could try and relate it to the OSI model, which I think most people learn at least in school. So when you're able to relate whatever you're learning to something that you already understand, I think it becomes easier for you to be able to understand whatever the new things that you're learning. So also in regards to what you said about the SMSC, I think most of the groups focused on SS7 being used for calling. We didn't bring out the other functions or applications of SS7, particularly the messaging bit and which protocol where and where it sits, like which protocol supports the different uses like SMS, USSD, and all that. But all in all, I think it's a good effort. And those of you who get into working in telecommunication, I think even like doing interviews and starting on the job, it will be easier for you once you've already understood these concepts. Yeah, thank you.
Okay. Evening, everyone. I hope I'm clear. Thank you, everyone. I think as most of the judges before me has said that SS7 is quite a difficult topic, and it's actually good to see the input that everyone has actually tried. So I also have the same feedback around. One of the feedback is just to try to have a simple call flow, especially around SS7 itself. Then the second one, I think the main topic was around SMSC, if I'm not wrong. So simple call flow around, the SRIs, how message is handled from the handset all the way until it is delivered to the customer will have helped also, and also how SMSC uses the SS7 to handle some of the issues that have been brought up, including advantages of SS7 like error handling. How does SMSC, which falls under the map, handles errors and such type of things? It will have made it also clearer when doing the presentations. And also, I hope, Kamochi, you can also give most of them some of the just sample traces to help them also understand how the signaling stacks look like. Because sometimes when you give someone a trace, they can actually quickly relate it from the lower layers, which is the IP, all the way up to the map layer. So thank you all for the presentation.
Thank you, Collins. I'll comment on that towards the end here.
So my comment, I'll echo especially the part for the call flows. The call flows are the lifeline of telecoms. Being able to see what moves from where to where, from beginning to the end. So a good understanding of SS7 can also be aided if you have the call flow with you. So that is my first comment. The second comment is also an appreciation of the general network. I think Brian's team tried to do that. When you map up the whole network, see all the network elements, and try and identify which network element could be an SCP, an SSP, or SCP, also helps you to better understand the SS7 stack, because you would see each of the layers playing out at all the network elements. So that will also help you better grasp how the SS7 SIGTRAN protocols work. Yeah.
Well, thank you very much. Marlene, maybe we can briefly step out for 5 minutes. Guys, don't leave. We will be on mute. Then we allow us to have some comments on how you guys performed.
Hello guys, thank you for being patient. The judges are back with the announcements. I'll pass it over to Kamochu to introduce who's going to give the announcement.
Yeah, I think I'll just be an STP and forward the request to Collins.
So I'll just first of all give feedback around how. I'll go to the first group, and I'll provide feedback around the different groups. So the first group, my input around it is just first of all, If possible, just try to relate the core network elements in your presentation, because we have the different elements, the HLRs, the BTS, the BSS in the SS7 setup, and also try to add maybe a simple call flow of just even pick a simple like call setup, how the SIGTRAN assists to do a simple call setup, or how it assists even to do congestion detection, like if you are trying to call someone and is on a different call, or even routing a call from one VLR to a different. So just pick a simple call flow, because as was said before, in signaling, the call flow assists you a lot. I can go to the second group. For the second group, I think the presentation was good. If you can also have a sample trace, it will also assist you much better. But other than that, I think the presentation for SS7 was also clear. You could at least provide the different components within the SS7 stack. You could even compare it to the OSI model. The third group, which was presented by Polycarp, I don't know if any of the judges have an input around group 1 and group 2 before I go to the third group.
I just wanted to say for group 1 and 2, it would have been good if you had internalized a little bit the theory, so that it's not textbook. You're able to relate it with actual functions that happen in the network. That would also help. So in the next presentation you'll be doing, it will be good to internalize that. Yeah.
Okay. Thank you, Grace. Any other judge who has feedback around that?
Personally, I think I also agreed with the sentiments, but also for group 1, I think they need to do better time management. I don't know whether it was a confusion on our end, but they didn't cover much within the time that they had. So on top of internalizing what the theory they are reading, they also need to, maybe when they're presenting, you need to prepare in advance so that you have an idea how long your presentation is going to take. Back to you, Collins.
Okay, thank you, Walter. I'll go to the third group. I think for the third group, it was all about being ready for the presentation. So I think they were not ready for the presentation, and also understanding the presentation itself, because I think there were moments where the presenter got stuck around trying to explain some of the network elements, like the SSP, which is a service switching point. So I think for group 3, if you can prepare yourself much earlier, because polishing your skills goes a long way for someone to actually understand what you are presenting. I can go to group 4. For group 4, I think the presentation was very clear. You actually showed us the different components, the BSS, NSS, and the OSS. You even categorize the different aspects within the BSS, where you have the BTS and the BSC. So it was clear that you actually understand the signaling stack, and also you also understand the OSS. So maybe my input around it is just maybe to go a little more detail into the SMSs that we had initially raised for us to understand the different how the map layer works. But I think maybe that could have needed more time. Also, around the same group, there was, you touched a bit around ISAP. I think maybe if you could have provided the examples around it, it would have also been great, because I think CBS has some components around it. So I don't know if we have any judge who has comments around group 3 and group 4.
Maybe let me just chip in on that. So for group 3, just to reiterate, I think next time just do more preparation. I didn't see any details given on the SIGTRAN stack, and also you looked like you're not sure of the concepts that you're talking about. I think that's it for me from group 3. For group 3, group 4, you showed very good understanding of the concepts. You simplified them for the audience to be able to understand. I liked the fact that you brought in the intelligent network. I think you're the only group that was able to relate TCAP to the IN, and also the calls flows for ISAP were very clear. So good work.
Any other judge to chip in? Okay, I can go to the last two groups. So we had group 5 and group 6. So my comments around group 5, I think group 5 was presented by Amos. I think it was Moronga. For me, try to have more information around the SIGTRAN. I think you didn't have the slide didn't have any info on the SIGTRAN bit. Also try to incorporate other network elements involved, because we have the BTS, HLR, BSS. But I also liked your presentation because it was detailed. You actually had call flows that actually explains how even a call is handled. So good work around that, for just to make it to have a better presentations around it. But kudos for at least trying to bring out some of the SS7 and the signal stack. So I don't know if we have any of the judges who have input around group 5 and 6.
Maybe I can just give a comment. Group 5, Amos was the presenter. They had an understanding of a good understanding on the GSM network, and a good understanding on SS7. However, they need to build more on SIGTRAN. I don't know, I didn't grasp much, or maybe there was no SIGTRAN was not presented. So maybe next time you can do more on SIGTRAN, apart from now the other things that we indicated to have more related to SMS, because it's an SMS project. Group 6, the presentation was okay. However, I think at one point it was so brief. There was no much information for SIGTRAN, and the SS7 information that you gave was so brief. So maybe you need to next time to invest more time to give longer presentation, considering that you still had more time, but the content that you had was too little. So maybe next time you just need to increase your content and maybe explain more on the slides that you are presenting. Back to you, Colin.
Okay, thank you. Any other input around group 5 and 6? If not, I can.
Colin?
Yes?
I didn't have input. I'm not specifically talking to group 5 and 6, but okay. I think from the group's presentation, what we understand is that the groups are supposed to appreciate the GSM network as a whole, and then go down to the signaling protocols. And from observation, I think it's only group 4 that actually started from that high level. And my advice to the groups is it really helps to start at that level where you appreciate the whole network. Because when you do that, it becomes very easy to see what is involved where during the communication at the SS7 level. So I would challenge the teams as they go into working on the SMSC, start by understanding the end-to-end network, the GSM network, and the high-level view of it. And then now come down, understand the SMSC, what it interacts, the platforms it interacts with, then come and understand which protocols do they use to interact with each other. That will help you actually relate the SS7 SIGTRAN communication with what you actually do when you pick up your phone to call, or when you SMS someone or you dial a SSD code. You'll be able to see that coming into life. Yeah.
Okay, thank you, Grace. Just to add on to what Grace said, some of these things you find that just try to internalize, like when you go to SMSC handles short message from one customer to, or one handset to another. So for the call flow, try to ask yourself, if I'm sending a message to Grace, how does that message reach Grace? If my phone was off when I went to sleep, and when I wake up in the morning and I switch on my phone, I usually receive all messages at once. How does the network know that I've switched on my phone and I start receiving all these messages at once? So understanding what happens when you do texting will also help you map, because once you say that you want to send a message to someone, then you map all those sequencing of what you actually do, helps you to know and appreciate what is this SMSC, what is HLR, what is CBS, what is a BTS. So based on how you interact with these, some of these GSM staffs will also help you to actually do the mapping for the whole flow within the SIGTRAN. Thank you. So I think I'll hand it to Juliet.
Okay, thank you, Collins and team. So I think we've come to the point we've been waiting for the whole evening, to announce those who will be participating in the summit tomorrow. And from our assessment, all of you did well, but we had to get some winners out of the group. So number 3 was group 2. Number 2 was group 5, and number 1 was group 4, according to the judges. So thank you all. Maybe we could clap for the winners.
Oh, there is a digital club.
There's a digital club. Kamochi, you are about to start clapping.
I had already started.
Okay. I am clapping.
Okay. So that's it from us. Humbled to have been part of this, and really, please, if you didn't win, don't feel like you didn't do a good thing, because from everyone here, they can tell you that signaling is not easy. It takes time to master it, and you master it through going through things like those traces, being able to now correlate that this element talks to this element using this protocol, and it comes with time. So I wish you all the best in the next phase of the challenge. I'd like to hand it over back to Marilyn, I believe, or is it Kamocho?
Yeah, I think Marlene, I can pick it up just to conclude. I have nothing else to say, just to respond to one thing that Colin had asked. Yes, this is week 1 of 8 weeks. So in the week 2, The challenge is for them now to dive deeper into the specific protocols that facilitate messaging. So in the next 1 week, this is what guys will be talking about. And tomorrow we'll be having a session. I hope you guys will attend. It will be a brief one, but the key idea is to try and identify what the functions, let's say, for example, map. What are the functions, the message format, and in addition to that, we look at the procedures that are supported. So we will not be taking you through that. You'll do it through group work, but tomorrow at least we'll share some of the dumps that can help you in analysis. So yes, Colin, so we are going to do that. And maybe the last thing is to thank all of you. Marlene and team, thank you so much for organizing this. It takes a lot of effort to just organize these things. They might appear simple, but they're very draining. So I know there is a team behind Marlene, and we really appreciate. Of course, the judges, we really thank you guys for coming through and sharing your experiences, giving comments, and at least we know we are not alone. That's the most encouraging thing. The only ask is that we have 8 weeks. I know getting 2 hours in a week is a tall order, but we will be notifying you when we need you. We will ask you. And of course, the final activity of doing a real simulation of the call flows for messaging with things created by the team. You'll be part of the people to be invited for that major event at the end of the whole challenge. To the group members, I think you've heard. If you thought SS7 was simple and signaling is simple, you are basically a superstar. So you've heard from people with 16 years experience, 13 years. There is no one with less than 13 years here among the judges. And they can tell you that you've done well. And I think Walter mentioned that some of you are doing IT and computer science. This is the first time you're here in a HLR. And for you to come and showcase what you have done, I think you've really done well. So we are really grateful. And we are hoping that we can have more and more conversations as we move forward. And for those who are hiding behind the presenters, I also encourage you guys to ensure that you are at par with your leader. So thank you so much. And yeah, Marlene, I don't know whether I'm supposed to say anything else. And for those who joined and they're not part of Natujenge, we really, the SS7 challenge, that is, we really thank you guys. We love community. And if we were just the presenters alone and the judges, it wouldn't be exciting. So thank you all for sparing this time and actually allowing us to extend by about 26 minutes. So Marlene. Yeah, maybe you can just wish guys a good evening, and then if you have any announcements, please let us know. Just a reminder, tomorrow we are meeting. Tomorrow is a packed day, but we'll still do a very short session, maybe 30 to 45 minutes, just to look at the challenge for the next 1 week.
So I'm hoping all the participants have stayed till the end, and please take note to participate in the activities, your group activities. Don't let one person do all the work, because at the end of the day, you don't get to learn much when somebody else is carrying the load for you. And thank you all for coming, and I see you tomorrow. Thank you. Good night, everyone.